Now we will continue with a presentation of Javier Aparicio Mijares, who studied at the School of Engineering from the UNAM and graduated with a master's in hydraulic engineering in 82 and in 85, PhD in hydraulic engineer with a distinction in the same division of postgraduate studies of the School of Engineering in UNAM within the Mexican Institute of Water Technology. He's been a specialist in hydraulics and coordinator of hydrology, a position he has right now. Dr. Aparicio has a ample trajectory in postgraduate studies and is the author of books. He has also published 118 articles and has received the Levy Award in 2004. And he's member of the Mexican Hydraulic Association and the National Researchers System. His presentation is on analysis and hydrological modeling of the quality of water in transborder areas between Mexico and the United States. Good afternoon to you all. In the first place, I want to thank the invitation extended to us by the UAM and INEGI to participate in this meeting. Well, will you please put it on the screen? I will talk about some work of the Mexican Institute for Water Technology, analysis and hydrological modeling, the quality of water, management of water in the Pacific coastline and transborder basins between Mexico and the United States. Well, first I will introduce the goals of my talk. Methodology of goals and results in the basins of the Rio Grande, Colorado River, Tijuana River. The goal is to produce databases, especially with a specific structure, which is ArcHydro for transborder basins, and make these the database
and the models on the quality of water, and the main goal is to compile all the geographic information systems with these management models so that the management of water is more efficient. And this hydrological model and the management models are carried out through WIP, water evaluation and planning system that was used for these water basins. For every sub-area, basin, and sub-basin, we have developed an information system on the surface, and then we create a WIP model for the amount of water. Then we develop again the ArcHydro and the AcroHydro, and then the WIP, and then we validate the models, and then we come up with the applications. And the ArcHydro data model is a model that takes into account the static characteristics of the information, such as the basins, the bodies of water, the streams, the spatial data, the temporary data, the seasonalities, the seasonal data, rainfalls, droughts, and so on and so forth, and all of this, and the runoffs. And in the case of the Rio Grande, we have here the location of the hydrometric and climatological stations. And we find here the stations that have been put to use. Now, it so happens that when we look at the maps with information on Mexico, after the Rio Grande and going up north, the maps are blank, and vice versa. when we look at U.S. maps where we need information on the Mexican side, on the south of the Rio Grande, maps are blank. And one of the goals we have here for this work is to come up with an integral system that will include all the existing information on the side of the United States and Mexico in regard to the international basins. And for surface hydrology, we have over 2,000 monitoring climatological hydrometric stations with over 5 million registries on both sides of the border. And this is an effort that is totally unprecedented in regard to compiling all the information and being able to plan the management of water in a joint manner between the two countries. And in regard to the international basins, in the case of the hydrography, the information for the U.S. at the scale of 1,000, and for Mexico 50,000 for the case of INEGI. In the case of the quality of water, we have here the map of the stations monitoring the quality of water on both sides of the border. In the U.S., we have many more stations than Mexico, but we have all the monitoring sites when this work was carried out for the monitoring of water for both countries. Over 4,000 points of monitoring points for both countries, as well as residual treatment plants or residual water treatment plants. Now, in regard to the archive data models, in the case of the Rio Grande, we have the ArcHydro for groundwaters, and we need information of 20 aquifers based on the survey, 74 aquifers based on the data provided by CONAGUA. And for the management model in regard to the amounts of water, the WIP Bravo, one of the screens we have for the WIP models in regard to the volumes of water, the amounts of water. And in principle, we used a binational project called the Physical Assessment Project that tried to assess many proposals for the management of water in the Rio Grande Basin, but this can be modified for different purposes in projects for the management of water at a binational level. In the case of the basin of the Colorado River in the U.S. Most part of the basin is in the U.S. and a small part is in Mexico. But in regard to the water limitation provisions dating from 1944, Mexico needs over 1 billion cubic meters of water that reach the border here between the U.S. and Mexico. And we have had many historical events, and there have been disputes between the U.S. and Mexico because of the quality of water, because of the brackishness of water. And Mexico, in spite of the fact that they have a fragment of the basin, is still an important actor in the management of the basin. And in the Rio Grande, we have 78 monitoring points and sites, the climatological hydrometric stations on both countries. And of course, we shall disaggregate the data in the web model, almost 2 million registries on each side of the border, the hydrographic network and the information, 1 to 100 and 1 to 50,000 on the Mexican side. We have here some examples of the WIP entries and exits for the quality of water from Falcon to the Gulf of Mexico. That stretch, we see the variations of the total solids in a station on that stretch, and the location of the stations that we have between the Falcon Dam and the delta, the estuary of the river, to the Gulf of Mexico. And we have here the ArcHydro model for the Colorado River. And in the Mexican side, in the U.S., we only have information about the wells. And this is due to the way the information is managed and handled, and the way the water is managed in the U.S. side, different from the way water is managed in the Mexican side. And on that side, the aquifers are private, and it is hard to have official information. So some of the outcomes from the WEEP management system for the Colorado River, and we are currently using information on 2 reservoirs and the channels and the streams and some operations policies. And I insist they can be modified at any time in order to be able to evaluate them in the model. Now, in the case of the Tijuana River, but this is a stretch of the Tijuana River that comprises many cross-border basins, Baja, Sonora, and Chihuahua, in the Tijuana Basin, and there are other watersheds that are here. They don't belong to the Colorado River, nor the Rio Grande, nor the Tijuana River, and that also englobes the information for the surface waters, quality of water in all these basins, as you can see here in the picture. And here, for instance, we have some results of the WEEP model in the basin of the Tijuana River, 204 users, including the cities of Tijuana and Tecate, 2 dams, 3 aqueducts, 3 aquifers. And here, amongst many other things, and this is performed in the other basins, the levels of rainfall and optimization algorithm, and we calculate the runoffs in the whatever season we choose. Okay, now that for the cross-border basins, Mexico, U.S., and we have applied exactly the same methodology to many other sites around the country. Recently, we worked on a geographical information system regard to the quantities, the volumes of water, and the environmental information in many basins in the Pacific shores, the coastal line of the Pacific. And here we need to develop an environmental and hydrological database in the ArcHydro, and that can be used as a platform for hydrological information in these subregions. And here, in light blue, we see the basins that were surveyed, that were utilized for this study. Now, these models of reference data, geographical information on every sub-basin, the sets of time and rivers, as I said, with the cross-border basins, that's the way that we did it too. Now here we have another example of what comes out from the data model, the hydrology, surface hydrology, the hydrographic network, the water network, the main networks as part of the geometrical network, and the mosaic of digital models, elevation models, of course with information from INEGI. And here we see part of the surface hydrology with the information of aquifers, the area of the study, and we find the delimitation of the aquifers in regard to the maps of INEGI 1 to 50,000 municipal and state maps, and the feasibility we have in many regions. And then my conclusions. The moderator will see that I took more time than was planned, but 3 exactly. The data that were produced can be used in the decision-making processes and international negotiations in regard to the cross-border sections and in the Pacific coastal line for the distribution of water between the hydrological subregions that are part of this zone. This is very important it's important to have information crucial on both sides management of the border, especially in regard to the binational watersheds, because otherwise it's very difficult to make decisions in regard to the management of water or joint decisions. And to me, I feel very enthused about the fact that this has been a very pronounced trend with the participation of actors from both countries, and that decisions are made on a joint base with goodwill decisions and a lot of participation. Besides this information, it is important to have a good integration of this data model for the geographical system and integrate them with management models so that they are well interconnected, because in this way we can considerably multiply the management capacity and the decision-making processes can be optimized. And of course, we have developments and updating of the database. The data are constantly changing, not only in amounts but in quality as well. And of course, it is necessary to establish continuously prospective scenarios in order to carry out adequate analysis based on the database and based on the support systems for our decision-making processes. So thank you so much.